So, hello guys, sorry for taking much of your time. I hear everyone. So, can you hear me? Can anyone hear me, please? All right. So, I will continue from where my colleague stopped right now. So, this is the full application. Let me share my screen. So sorry. Please react if you can see my screen. All right. So, let's start. All right. This is the packages that we use in our project. We use dice bay avatars for generating random avatars, and then we use ChatCN UI, and then JS. We use this Lucid React for icons, and then React Autos for those notifications. So those are the main packages we use in our projects. And let's start from the first part, which is this connection JS. So this is the way we connect to the CrossFi chain. So here we use define chain, which is coming from the Rion app kit. If you fork this repo from GitHub, have you ever forked this repository? All right. So if you have this repository with you, you should have this define chain, which is the ID. This is the chain ID 4157 from CrossFi. So let's go to the CrossFi documentation to see how this was gotten. Coming, CrossFi. All right. So okay, starts these developers connect the front end. Okay, this is how it was made. This is the mainnet. Why this is testnet, which we'll be using right now. So we are using testnet. This is how it was set up. So you just have to copy it from here and then add it to your project. So this is AIP 155, which is the and then the name is CrossFi testnet. This is the native currency, which is X5, and then this is the RPC URL. And then this is the block explorer URL. All this has been set up in our environment variables. This is the RPC URL. This is the explorer. Then you pass in your project ID from Rion AppKit, which is inside this environment variable. And then this is the metadata that shows when you want to interact with this website, with this application. So here we create app kit with this, and then we pass it as provider. So we use this provider to wrap our app. Here, where's the layout? This is the app kit provider, and this is the children. So we use this app kit provider, which is this connection, to wrap our app so that whenever we are interacting with this, it will be connected to the chain that was connected with this connect button. So in the header here, we have this app kit button, which is web component. So this app kit buttons is what is allowing us to have this button here. Where's the app? This is the button. So with this app kit button, it gave us this connect button. So if I should remove this now, we want to see this connect. Let me refresh. You can see we don't have this connect button anymore. So we need to return this app kit button to make us get connected to the app. So it is this that is helping us to power our app, and then connection to the wallet. Now we have this component, which is contribution component. We have the header component, we have the memo section component, and then the owner card. So I will explain all this. But right now, let's go to the constants. The constant, we have the contract JS, which is where we have the ABI. So the ABI is application binary interface, which we use to connect our front end with smart contracts. So with this ABI, it defines all those functions, interfaces in our smart contract, which are the you can see this is the event name memo. This is buy coffee, which is a function. You can see the type is a function. This one is an event. So with this ABI, we'll be able to interact with our smart contract from the front end. And this is the contract address that was deployed. I'm sure everyone here has his or her own contract address they used in the last session. So this is the contract address I used. So this is the read-only provider. So we can make two different types of transactions with our smart contract. One is we can use a read transaction, and then we use one to write to the smart to the chain. So with read transaction, we use ordinary JSON RPC provider, which is for read operations. And then for write operation, we use the signers, which we get to very soon. So let's go to the first component, which is let me go to the browser, which is the header. Now, what do we have in our header? This is the components. This is the header. Okay, I've done the header. So we have the contribution form, which is the form you have here. This form you have here. So I'm coming. So this is how it was made. This use app kit provider is a hook from we own app kit. And then this EIP 155 is the namespace. We have different namespace for different chain. For Solana compatible chain is Solana. We have Cosmos, but this one is for EVM chains, which is EIP 155 namespace. And then this wallet provider. Then we use browser provider from Ethers.js. So it is this browser provider that's converts Ethereum provider of Frontend. Okay, it is this browser provider that we use to get our signers, which we are able to sign transactions. So from this provider, we use await provider dot get signers. So with this type of contract, we can create both write and read operations with this kind of contract because we have the signer. So the signer is the one with the private key from our EOA, which is externally owned account. So we create a new contract instance. We pass in the contract address, which we have inside our constant.js here. So this is the contract address, and then this ABI here. And then the value is the amount we pass in. So big 8, since it's a big number, then the decimal is 18 decimal. The token we are using is in 18 decimal. So amount times one exponential hinting. So that's the value we are sending, which is the native token. We use the native token of CrossFi is XFI, which is XFI. So we pass in the value here of 18 decimal, and then we call this buy coffee, which is a function in our smart contract. If I go to the smart contract part, where is it? So let me go to others contract, and then buy me a coffee. Let me zoom in a bit. So we are calling this function, which is buy coffee. So it takes in two parameters. One is the name, and the other is the message. So that's what we are passing in our, yeah, you can see contract dot buy coffee. Then this is the name, this is the message, and then the value. The value we are setting, which is the native token, which is the X file, which is MSG dot value here. Where is it? This is MSG dot for value. So the global variable, and then we wait for the transaction. This is the transaction response, and then this is the transaction receipt. So we wait for one confirmation, and then the timeout is 40,000 milliseconds. So this is the timeout, and then once it is successful, we show a toast notification that coffee bought successfully. So that's about the this form here, this buy form. This is the name, this is the amount, which is the value, and then this is the message. So by clicking this buy coffee, we trigger this function to buy this function, undo buy coffee, to buy the coffee. Then to get the memos that was created, which is all these ones down here, we go to this memos section. Yeah, so these are the use states for setting the memo, and each memo. This is the loading, set loading. So yeah, we listen to an event. So the event that's being emitted from the smart contract. So if we have someone that add a memo to the smart contract, this event will be emitted, and then it will listen to the event and then update the UI. So assuming we have new events such as buying a coffee, which is I think that's the only the current read write operation here right now for other users. So whenever we have a new coffee, this recent memos will be updated with the latest memo. Yeah. So yeah, this use effect, we use it to fetch the memos in our smart contract. So it will be triggered once the DOM element has been rendered. So whenever the component mounts, so it will be rendered just once. It will trigger just once. So this is the function to get memos. Here we are using, instead of using signer here, we are using provider, which is the read-only provider. So you can see it is coming from the read-only provider. Since we are not doing a write operation yet, we are just reading from the smart contract. So here we are doing new ATAS.contract. So we are creating a new contract instance here, same way we did with the signer. So the contract address, the contract ABI, and then the read-only provider. Now we are calling a function which is the get memos. That's the read operation. Let me go to the smart contract and see what's in the get memos. Yeah, this is the get memos. It returns array of memo. So this memo is a struct. So it returns the array of this struct. This is what it will return. All memos we have in our smart contract. So that's what it will return. So this is it here. Now we need to format the memo, because what we have in our smart contract is not actually, some will not be readable to us, just like the timestamp now, because timestamp is in seconds, which is the Unix timestamp. Yeah, so the timestamp will be seconds. So we need to convert it to readable time. Yeah, and then we have the amount. So we need to format it to the real value, because in our smart contract we set it to 18 decimal, which is for precision accuracy. But right now we need to format it back to the default value. So now we use format ether, and then we pass in the amount, which is memo.amount. If you come to the struct here, we have amounts, we have the name, the timestamp. So the ones we have issue with right now are the name, sorry, the amount and the timestamp. This one will be in seconds, and then this one will be in 18 decimals. So we need to format them. So format ether, it converts, it removes the 18 decimal and then converts it to its real value. Now to fix 4, which means to 4 decimal places. Now we are converting it back to number. And then here, we are creating a new instance of the date. This new date, and then we are converting it back to local date string so that it will be readable for us instead of seeing numbers. Where is, okay, this is. So it will convert the dates to this format, and then to fix 4, we convert this to 4 decimal places. So now we are using dot reverse. Dot reverse is just to sort it in descending order so that the recent memos will come to the top, and then the old memos will go to the bottom. So that's why we just use dot reverse here, and then we are setting memos to the formatted memos that we have in our smart contract. So this is where we are rendering them in our browser. Memos.map. We are mapping through the memo and then creating a collection of this. So we are generating avatar. With this generate avatar, we're able to generate random avatar based on the address of the user. Are you with me? So we're able to generate avatar based on the address of each user. So each user we have different, each address we have its own unique avatar. So this is coming from dice bar collection. So this is the function that generates avatar. So we can generate different type of avatar. So this one is for personas. So if you come here, we have different collection. I can decide to use kudos. So if I should do it like this, where is it? So the avatar we change to different type of avatars. All right, so let me continue. So that's that with the memo section. So this memo section is just for read operations. Let me go back. Let me undo what I just did now. Now, we are done with this contribution form and then this memos section. All right. Now, let's go to the owner card. This owner card is the person that deployed the smart contract. So the owner is the one that owns this smart contract. We set it here in the constructor. Owner is equal to msg.sender, which is the person that deploys this smart contract. We are setting it just once here. So we have the owner card here. What are we doing here? We are checking the address of the owner to make sure that whenever the owner interacts with this app, this UI will be different from when it's not the owner. So if it's the owner, we won't be able to see all these forms because we don't want the owner to contribute to himself. We just want him to be able to withdraw the tokens that were sent to him. Now, here in our app, let me go to the page. Okay. This is where we are checking for the owner. So we have all these utility functions. So from the use app kit, we're able to get the address and then the status, which is if it is connected or not. Then what we need right now is the address. So we want to compare the address of the person that's connected to our app to the person that deployed the smart contract. There is .owner in our smart contract. If we check, let me go to the smart contracts. Yeah, this is a public variable. So with this public variable, we're able to create a getter function. So this owner is just like a function and then a variable also. So it will create a getter function for this owner variable. Now, this is what I'm doing here. In this use effect, I'm fetching from the smart contract if the owner is the one that's connected to this app. So same way we did, we create a new contract instance with this, and then let me just zoom out. We are calling contract.owner, which is this owner here that was saved in this constructor. So if the address matches, so we are doing if owner.lowercase to make sure that both owner in our smart contract and then the address of the person that's connected to this app, we are converting them to lowercase. And then if it is true, then it will set its owner to true, else it will set its owner to false. So if the owner is true now, what we do? We are trying to get the contract balance. So here we are doing provider.get balance. Which balance? Because it is a native token. So we use this get balance of this contract address. Now we are setting the balance. The same way we formatted the amount, so we will have to format this also so that it will be readable to us instead of making it in 18 decimals. So that's what we set here. So this is where we are making the card dynamic. So if it is owner, then it will show the owner card. Else, it will show the contribution form. Now, what do we have in our owner card? We've gone through this contribution form. So this contribution form will show if the person that is connected to our app is not the owner. Now, let's go to the owner card. Let's see what's in the owner card. This is what we have in our owner card. We have get your coffee, and then we have a button to withdraw balance. Let me switch to the owner now to see how the UI looks like if I'm connected as the owner. Let me log out. Let me disconnect. Now, let me connect as the owner. Let me change this to another address. Let me use this owner that deployed. So yes, updates, connects. Now let me just refresh. Let me switch the chain. Which chain am I in? Okay, let me switch to CrossFi testnets. All right. Disconnect, connect. Now let me change the address and select this. So here's the owner, updates, connect. Yeah. Aha. So this is the owner now. You can see the UI is different. Once it's the owner, we have a different card, which is for the owner to withdraw his balance, since it was able to detect the owner by comparing the address of the person that is logged in and the person that deployed the smart contract. So here, this is the undo withdraw function. Here, we are creating a new provider instance from the wallet provider so as we can create a write operation by getting the signer from this provider. Now we do await provider.get signer, and then contract is equal to, we created a new instance of a contract, and then we are calling the withdraw tips function. This withdraw tips is a function from our smart contracts. Where is it? Withdraw tips. Yeah, this is the function we are calling. So what are we doing? We are doing owner.call. This is a low level call. We are calling, that is, we are sending this value from the balance of this address, which is the balance of this smart contract, to the owner. So this is a low level call. We get two data, two responses. So one is the success and then one is the data. Now we are checking if it is success. If this one is true, else it will return transfer failed. So we are requiring this one to be true. Now, this is what we are doing. Now we are called this withdraw tips. With this withdraw tips, it will withdraw all the balance of this smart contract. So let's try to withdraw. Let's try to withdraw and see what happens. Yeah, so let me just withdraw balance. So I will have to sign this transaction in my wallet. So confirm. So let's just wait for the, we set it as after one confirmation, you should have to wait, and then the timeout. Yeah, withdrawal successful. So I've been able to drain all the funds in this smart contract. So let me check my balance. Okay, it's not getting updated. I don't know why. I think there is an issue somewhere. Let me just change this to the. Okay, yeah, I have it here. So activity. So this is I call this withdraw tips function. Yeah. So it went through, it was confirmed. So now let me view it on Block Explorer. Why that is loaded? Okay, it has loaded. So this is the, you can see 1 minute ago. So this is the commission, which is the fee. And then not transferring token. Commission, okay. Assets 0x5. So this is the contract call. This Explorer is not showing well. All right. Let me switch the account and create a new memo. Let me just donate to this user. Let me donate. Let me switch accounts. Let me just use an account that has font in it. Edit. Which account has font in it? Let me use this. Yeah. I think I have font here. Let me update. Let me just refresh. Also, this thing is not connected. I don't know why. It's not updating. Let me just disconnect again and then switch accounts. So edit. So let me use this second account. Let me just up this. Update, connect. Yeah. Okay. Now let me just donate to this smart contract. Let me give it. Let me just call it Rocky. Okay. Thanks for the tutorials. Thanks for the tutorials. Okay. Tutorials. Now let me just buy coffee. So I'll just confirm. Yeah. So I should have my new memo added to this memos list. Let's just wait for the transaction to be confirmed. So once it is done, we have a toast notification. Yeah, coffee bought successfully. Let me just try to refresh. There's a problem with this RPC URL. So it's taking some time to update here. So we have this is the new one that I created, and then this is the amount that was sent. And then you can see the date 21/12/2024. So, and this is my address, the address of the donor. So I think that's about that. I'll be able to cover this connection and then this. So I forgot to tell you what we used to power this was Shard CN UI. Yeah, Shard CN UI kits. So with Shard CN, we're able to get all these headless UI, such as these forms, these buttons, and then other reusable components. So if you come here, UI, we have the button, we have the card, we have the input, text area, and alerts. So with that, I'll be able to cover all this, the front-end part of this app. So we can donate and then we can withdraw from the smart contracts. So if you have any questions, please let me know.
All right, guys. We thank you all for joining this office hour, where we have been able to cover the basic stuff that is needed for front-end integration with a smart contract that is developed and deployed on the CrossFi chain. So, if we enjoyed the session, I want us to reply with a reaction. Just clap. Just clap. That reaction, that clapping reaction. Let's go, let's go, let's go. We have one, two, that's three. I'll be counting. 4, 5. Okay, you guys are not clapping. Does it mean you don't enjoy the class? Okay, thank you, thank you, thank you. All right, so we have Mr. Herman Stark that has his hand raised up. You have a question for us? Please carry on.
GM, everybody. So, sorry, can you hear me, please?
Yes, we can hear you.
Yes, thank you very much for the session, and I really appreciate all you have been doing since morning. It's very nice to be here. Thank you once again. So, I want to use this medium to make this announcement to everybody that is on the call presently that um there will be a code that will be given out to people that actually join this event at the end of the call. So everybody should stay glued to the end of the call, and they will have to send the code to blockchain Lautech community and the admin contact for some rewards that will be disbursed to them with the code and the screenshot of their of them attending this particular meeting. So that's what I have for you guys. Thank you once again. Please, am I clear? Am I clear? Am I audible enough?
Yeah. We got you. We got you. All right. So that
Thank
was
you.
not a question. It is just an announcement from the from one of our partners, Blockchain Lautech. All right. So do we have anyone here that would like to ask a question or two? Okay. In the absence of questions, we are going. All right. Once again, we say a big thank you to everyone that joined this session, and hopefully, we are going to reach out to you again if there is going to be another office. Thank you, thank you, thank you, and have a blessed. Uh,
So sorry,
okay.
please. Sorry. Sorry. And thank you for that closing remarks, sir. So now I'll be stating the code for them to collect the rewards. Sorry, can you hear me?
Yes. Call the code.
Yes, the code is BCL, capital letter B, capital letter C, and capital letter L. So just